Okay, seems like we're now live. Hope you like the new holding page. Okay, so last night I was thinking about where I want to go with this channel, and one of my hobbies outside of work is I like to make offensive tools. Offensive as in offensive security tools, not offensive as in telling you to go and do one. I like to make offensive tools, or I like to make automation tools to improve my workflow. I typically like to work with PowerShell, Python, C Sharp, and Bash. I mean, those are the sort of four staples that I use on a pretty much daily basis. Okay, so where I'd like to go to with this channel is I'd like to get you to a point where we can start, just making tools on the command line every day, and show some of the stuff that I'm making. I mean, at the moment, I'm actually working quite a lot with ChatGPT. Well, not really ChatGPT, that's the front end wrapper, but OpenAI, and I'm bringing that into some of my tools, and I'm working on some very sexy bits that I want to get to show you guys. But I realized that if I don't really teach you the basics of these languages, I'm going to have to send you off elsewhere to other channels to learn the basics, and I can never be sure that you've actually learned the stuff that I need you to know before I go on to the more advanced stuff. Now, today I want to start introducing Bash. I've done 2-hour talks on Bash, of just the advanced Bash. To be honest with you, I could probably talk about Bash for 10 hours. Okay, now I don't want to go for 10 hours straight streaming today talking about Bash. There's just not enough water in front of me. Well, I have solved the heating issue that I was facing yesterday. But I do want to have a condensed session when we go through all the fundamentals of Bash and we get you guys up and going with all the basics. And then I want to go into some more intermediate stuff and then some really advanced stuff. And I want to look at, when we get there, we'll get there. But stuff that's going to really make your life easier on pen tests, engagements, or, when you're doing your DevOps stuff. And as I said, we'll get there. For now, though, I want to talk about Bash at a beginner level. So this is a beginner level video. If you want to skip to the next video, it should be ready by the time you see this. So just skip on YouTube. In fact, I should be able to put some links in, and I know people point to various places. I'll try and put a link in. But for now, I'm going to go straight into some Bash, and I'm actually going to teach you from VS Code. Now, you don't have to use VS Code for this. You can use any program you want. I mean, as long as you've got a Bash terminal, or to be honest with you, you don't even need a Bash terminal. Most of the stuff we're going to look at is POSIX requirements. So if you're using Z Shell, a lot of the stuff that we're looking at will work. But if in doubt, or if you're using some funny shell like Fish or something like that, it might do you good just to type Bash into the terminal to make sure that you are in Bash. So you could just do Bash like that and we'd be in Bash. Press Control L to clear the screen. So that's what I'm doing every time I clear the screen, just Control L. So I know a lot of people do the clear. It's just, it's too much for me to type out unnecessarily. So we're in VS Code. Now, let me just make this, have I got enough real estate? I'll take my camera off a second. Now, just on my pillow. So this is going to be a big one. Okay, so what we're going to do today is we're going to start with the very, 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 very basics. Now you can see in my bottom window of the VS Code, I've got a terminal, and this is one of the benefits of working in VS Code. I can see a terminal, but I can also start writing code inside a file. In fact, actually, there's pretty much space, so I can actually just put my camera back on if you want to see my ugly mug. So the first thing we're going to start off with all these languages we're going to look at is variables. Now, variables hold data. They hold things like strings, numbers, output of various responses to things, command output. So variables are one of the first things we'll look at in these languages. And setting a variable is so easy. So in Bash, to set a variable, all we need to do is give it a name and then an equal sign followed by the value. Okay, it's that simple. So let's just give our variable a name. In fact, actually, just to prove the point, we'll call our variable name. Okay, it doesn't have to be name, it could just be anything, but we'll call it name, like so. I'll do an equals. I'm fed up with the Billy Bob, so let's do, I know, John Doe, not very original. So we've got a variable now called John Doe. Underneath it, I'm going to put another variable called age, and John's going to be equal to 21. Okay, so we've got two variables now on the command line, and if you notice, the top one's a string and the second one is a number. If we wanted to output these, we could just return and do an echo, and I could output the variable. Now, don't just do echo name, because that will echo out name on the command line. What we need to do is prefix our variables when we're referencing them with the $sign. Okay, so I'm going to save this, and then I'm going to run the script. Now, this file has not got any executable permissions on it. So if I go to the terminal a second to give you an idea what I mean, if I just do LSL, you can see that the execution bit is not set on this file. I don't want to go too much into Linux permissions on this particular video, but just for now, just follow what I do. And what I'm going to do is I'm going to add the executable bit to this, so we have an execute. At the moment, we can read and write this file, but we can't actually execute it. So there's no actual executable permission here. So if you just do chmod on the, let's get the mouse out of the way. We'll do a plus and an X, and then we'll do the file. And then if I do an ls again, you can see now that we've got the executable permission on this file. Now, if we didn't have the executable permission on this file, we could still run it if we were to do something like, bash script, and that would have run anyway. But with the executable permission on the file, we don't really need to prefix the word bash in front of the script, and we can just run it. Just clear the screen. So I'm going to run the script. Now, the script's printed out John Doe. It hasn't printed out age, it's just printed out the John Doe, which is the name, because that's all we referenced inside or on the line of the echo. So that's how we would set a variable. Now, the next thing you might want to do is unset a variable or clear a variable out. And we can do that in bash by using the unset command. So if we had, let's go to the command line a second, we'll do the same thing again. If we do name equals John Doe, like so, and then we did echo name, you can see now we've got the John Doe variable. If I now do unset, and then I do name, and then I do echo name, you can see we've unset the variable. So that's the first thing. So that's setting variables, and you can see that we've actually set a number. We could turn this into a string by enclosing it in quotes, and we have set a string. So just for now, that's how we set variables. The next structure I want to look at is looping. So there's a couple of constructs that are common to most languages. So there's things that apply to most languages like looping, if conditionals, methods, classes. Now, Bash hasn't technically got classes, but I'm going to show you a workaround in this video of how you can do that with Bash. It's not a typical class that you're going to find when we move to Python and PowerShell and stuff, but it is a good workaround. So things like looping, if conditionals, methods or functions. Methods are typically associated with classes, and that's the correct nomenclature, so I should use that on a beginner video. Functions and things like this. This is what we're going to look at next. So what I'm going to do, I'm going to just clear this off in the file, and I'm going to create a new variable. Now, this variable is not going to be a string, it's not going to be a number. We're going to create an array. Okay, so I'm going to do, this might get a little bit big, so I might actually need to go to the code. Let's go here. So I'm going to set a variable called, let's see, fruits. We'll call it fruits. And we'll put the equal sign again. Now, to set a variable that's an array, we need to use the brackets like so. Okay, so I'm going to say fruits. Let's pick a fruit, an apple. Hesitation was there. Obviously, I don't eat enough fruit. Banana, and a cherry. Okay, just the first thing off the top of my head. So we've set an array. Now, an array is a collection of items. Notice in Bash, you do not have any commas between these items. If you're coming from another language, you might see arrays using commas. So, for example, PHP. But for now in Bash, we just basically put a space in between the variables and we enclose them in strings. Now, let's say we wanted to loop over this array of fruits. So let's say we wanted to do a loop over this array of fruits and we wanted to print each fruit out. So we can do this with the for command. So we do for. Now we need to pick something that's going to identify each of these fruits as we go around. Now, I don't want to make it too confusing, but I'm actually going to use fruit. But we could use something like I, and you see that commonly, I for iterator, but not really for. It's not really great for code readability in this case. So I'm going to pick fruit. Okay, so fruit. And then we say for fruit in. Now we need to list our array. Okay. Pardon me. We need to list our array. So I'm going to put double quotes. And inside here, I'm going to do a $, open close bracket, and I'm going to put fruits, which is the name of our array. I'm going to put the square symbols here, and inside there I'm going to put the @sign. Okay. Now that is the first part of our loop. So for fruit in array. Now we need to tell it to do something and loop over it. Okay. So we're going to use the semicolon. And we're going to say do. I'm going to do a line return. Now, whatever we put here is what's going to be done on each iteration over each fruit. So it's going to go apple, then it's going to go banana, then it's going to go cherry. So I'm just going to do a couple of little spaces here, and I'm just going to do fruit like that. So that's going to echo out the fruit. But if we left it like this now, the actual bash parser wouldn't know that we've actually finished the loop, so we're just going to put a done in. Okay, so if I just save that now, go down to the command line, and oh, there you go. So basically, did I not do? Oh, this is why it's always good going live. So it's not brackets. It's the code basis. There you go. Brilliant. So it's actually quite hard to manage a lot of this OBS and the cameras and the lights and that kind of stuff and actually teach. The teaching, unfortunately, is getting probably like 30% of my attention. So apologies, but as I get better with all the individual stuff, I'll be able to focus more on the technical part for you. Okay, so we've looped over the array and we've printed out each of the fruits. So that's how we'd loop over something like an array of items. And now this is good if the items are fixed. But if we wanted to loop over something a certain number of times, or we wanted to make a certain number of iterations, it'd be pointless to make an array of 5 items just to loop over 5 things if we didn't actually need the content of that array. So what I mean by that is, let's say we wanted to loop over 5 things or 6 things or something like this. I shouldn't say loop over something. I should say, let's say we wanted to loop around, say 5 or 6 times. It wouldn't really be, there wouldn't be any point to make an array of 5 items if we're not going to actually use those items. So we'd use a different kind of for loop. Okay, so let's go for a different kind of for loop. And what I'm going to do on this different kind of for loop, let's just get rid of that. So for this loop, we're going to do something like for, let's use the I iterator on this one. So for I, because this is probably how you'll see it used for this kind of loop. So for I in, so same syntax as last time for the fruits array. The difference here is, again though, we do need the curly brackets, not the standard brackets. And then we just say, let's loop over something 5 times. Okay, so we'll say 1, 5. Now, this here is a special syntax to generate a sequence. So we're going to say for I in, and then we're going to put this syntax here. It's going to go from 1 to 5. These dots here is what makes the magic happen. So it stops us having to make an array of 1, 2, 3, 4, and 5. Now, again, I need the semicolon, I need a do. Let's go next line. And then I'm just going to do echo. And this time I'm going to echo out the I. Again, though, if we just wanted to do something 5 times, we don't really need the I. So if you just wanted to, do whatever you're doing in here 5 times, and we didn't need the I, you wouldn't need it in there. So that's the difference. With the array, you kind of are doing it on purpose because you want to reference each of those items, whereas with the sequence syntax, you are just looping over X number of times. Now, in this case, we are going to use the I to give it some kind of visual output. It's like so. Let's go back to our script, Control L, up. And you can see now we've looped over the I, but we've done something 5 times. So this could be anything inside here. This could be a command, a number of things that you need to do. Okay, so that's a loop. There are also other loops as well. So the for loop kind of iterates over things, whereas the while loop, which is another loop, it kind of does something while something is a true condition. Okay, so you could say why a number is less than. So if we were going to do the same loop again, let's say, so we could say, while a number is less than 5, do something, but as soon as it gets above 5, we don't want it to happen anymore. So the for loop is an iterator where you're going to go over something a number of times, while a while condition is really good if you want to test if something's still true and you're not quite sure of how many times you might need that thing to happen. So let me give you an example. So if I was to do the same syntax again in a while loop, I could do something like counter equals 1, and then we'd do something like while. Now this syntax is going to be slightly different, and we're going to look at this syntax when we look at if statements, but we're going to use the square brackets this time. So we're going to do square brackets like so. We're still going to do semicolon, and we'll still need a do, and we'll still need a done. So at the bottom end, we'll need a done, like so. And inside here, we will be doing something. Okay, so in this case here, let's say we wanted to echo out the counter that we're going to make. Okay, so we're going to echo out the counter, and then I'm going to increment the counter each time. So I'm going to say counter plus plus, and then inside this while loop here, I'm going to say while counter is less or equal to 5, let's say, do this. So let's go back to the terminal. And you can see we've got the first loop here going from 1 to 5, and we've got the second loop here going from 1 to 5. So that's a while loop. Now, we need to discuss these square tags, square brackets, in more depth. So these brackets are normally used for things called if conditionals. So in Bash, you'll see 2 types of if conditionals normally written, either using 1 set of square brackets or 2 sets of square brackets. Now, the issue is the single square brackets, they are what we'd call POSIX compliant. Okay, so there's a POSIX standard, and that's what you can expect on most machines as a bare minimum compliance. So if you're trying to make something work for older machines or legacy machines, you normally want to use the single square brackets. However, the double square brackets is actually a newer standard. It's not POSIX compatible, but it came out in Bash version, I think it was version 2, I think it was. And basically, by using the double square brackets, it allows us to do. We'll go probably into it a little bit more into some of the advanced stuff, but it allows. It changes how we look at like wildcards and things like this. I don't want to go too much into it now until I've showed you some if statements. Let's just quickly have a look at some if statements. I'm going to clear off this. Just go back to where we were. Save that file, get rid of that. Okay, so let's make an if statement. And we'll say if, and let's do, I'll tell you what, we'll do a single square and a double square. So let's just do a single square bracket, like that. So we're going to do if. Now, instead of like with the for and the while loops, you do while or for, and then you say do something. This is an if, then syntax. So it's like if, then, and then to end the if statement, you can use the fi syntax. So if something, then do something, and then this is the equivalent of the done that we saw before. So in this case here, we could say if, let's put a little variable up here, actually say, let's go x equals 10. Say if x, now we put a dollar sign because we're referencing the variable. So if x is, let's say, greater than 5, then do something, okay? So we say, in fact, actually what we could, yes, let's do that. Okay, so let's do that and we'll echo out x. So if x is greater than 5, we'll echo it out. Let's save that. Let's test this out again. Okay, so it echoed it out because x was greater than 5. If I was to put this now and change this to just the 1 and printed this out again, you'll see nothing came out because the condition wasn't met. Now, you might actually want to generate some kind of message or error to say the condition wasn't met. And this is where we get to the next part of the if conditionals, which is if and else. Okay, so let me just adjust my chair. Let's go if, and then we'll say else, and we'll say something like that. Okay, so x was not greater than 5. So now we've got x is not greater than 5. But if I go back up to here and I put the 10 back in, the first part of the condition is going to be met. So x is greater than 5. So we're going to say like that, and we're going to print out x. So that's if conditionals, and that's the single square brackets. Now, in this particular example, this would work with the double quotations. So we could, the double square brackets. So we could do double square, like so, save. And in this instance, this would work as you would expect. As we move on into the intermediate video, we'll start looking at like wildcards, and we'll start looking at testing commands exist, and we'll start looking at paths and things like this. That's when the difference between the square brackets and the single square brackets and the double square brackets will really be evident. Okay. So we've done if statements. I think we'll go for let's combine them actually. Let's combine them. Okay, so what we could now do, so we've got this if conditional here. I'm just going to select it all and I'm going to tab out like so. And I'm just going to start tabbing this. And what we could do is we could say for I, so if you remember last time we had the iterator, so for I in, we could use this syntax again. So we could say 1 ... 10, and then we'll say do. This is the thing we're doing, and then we could say done. So now we've mixed the for loop and the if conditional. Now this won't quite work yet because I need to change the x's to i's. Because remember, this is still at the top there as x, and we'll just do I. So, and if I come back down to the command line, just make this a tiny bit bigger so we can have a look. So you can see there that while it was going round, I kept changing number. It went from 1 to 10. And as it got above 5, we started to print out the number because the first part of the condition was met. It was greater than 5, but everything else, it wasn't met. So we have the message. So we've got the if conditional now inside the while loop. We looked at some variables. Let's have a look actually at adding some numbers and concatenating some strings, etc. So getting loads of updates. No, do not update my computer. Okay, so let's take a number. We'll call this number 1, and that's going to be our variable name. And let's say 5. Okay, so we're going to take the number 5. Let's take a second number. So we'll call this number 2, and let's go for 7. Okay, so number 5, number 7. If we wanted to add these together, there's a special syntax that we need. Now, in other languages, you might think, well, we could just do something like, sum equals num1 plus num2. That wouldn't quite work as you expect. There's a syntax that needs to encapsulate these numbers in order to indicate to Bash that you want to sum up some numbers. So we'll make a variable called sum, and we'll go equals. But what we're going to do is use the $sign. I'm going to use some double brackets, and then I'm going to do num1. I'm going to do num2. So now I want to echo out sum, like so. I'll save that file. Let's go back down to the command prompt, like so. Let's clear that out. And you can see now it's added the 5 to the 12. So that's how you can add numbers up together using that syntax. Let's do something similar with strings. So let's say we have, let's do a hello world. Everyone likes a hello world example. So let's go into this and we'll do, in fact, we'll keep the same format. So string 1, and we'll call this hello. And we'll do str2, and we'll call this world, like so. Now, let's just say we'll call this output equals like so. And then we'll do string 1. I'm going to do string 2. We'll echo out the output. And we've basically put hello world onto the command line. So that's how we concatenate strings. The next thing that we might want to look at is functions. So functions are really good in any language when we've got a specific unit of work or specific requirement of what we need to perform. We can put it into a function, and eventually what we'll look at is making function libraries, and libraries are functions that we can import into our script so we haven't got to reinvent the wheel. So let's make a quick function now. In fact, I need a drink of water, so let me just quickly get my bottle. Okay, so let's make a function quickly. Well, there's no rush, but I'm just eager to get us to a point where we can start making tools, etc. So I'm going to make a function, and we'll call this function, I don't know, greet. So it's a greet function. And we'll do something like this. So that's the function syntax. And then inside here is where we put our function. Okay. So what we're going to do, we're going to pass a parameter actually to our function. So let's do something like hello. And then we want to echo out hello, and we'll put a person's name in. Okay, so we'll greet someone. Okay, so we'll do hello, $1. Now, the $1 inside a function is going to represent the first value that gets passed to the function. Likewise, $2 is going to be the second value passed to the function, $3 and so forth. There's actually, and we'll go to more advanced use cases in a minute, but just for now, let's just concentrate on this function. So we've got hello, $1. So to call this function now, we can just go down here and go greet, and let's put in Let's put John Doe back in again. Okay, so John Doe, so greet John Doe. Let's save that. And let's just run this. So you can see now we passed John Doe to this function. We never had to put the hello in here. It says hello John Doe. You might want to put a comma or something in there. I don't know what you want to do in there, but you could let's just say that. And you can see now that if I was to do greet again, I could do James Bond, however you want to use it, whatever name. And let's just run this again. So you can see now we've used our function twice, the greet function. We've passed in two different strings, and both times it was prefixed with the hello command. So hello John Doe, hello James Bond. Okay, so that was functions. Let's have a look actually while we're here actually of importing them into a file. So let's make another file. And let's do a new file on this system, and we'll call this file. In fact, actually, what we're going to do is inside here, we'll make a little to make a lib folder. And actually, no, just let's make a lib.sh for now. Okay, we'll make a lib.sh for now. I'm going to take our function outside of the lib.sh, outside of the script.sh. I'm going to put it inside lib.sh. So that's our function. So is my stream okay? Yeah. So we put inside our function here. Now to get that file inside of our script, if you like, we need to source it in. So we need to source in lib, and then we can use it again. So if I was to do and run this script right now, you'll see now that greet's not found because this script has no knowledge of the greet function. If we do source and then we do lib.sh in this case here, you'll see now that we've sourced in, I don't know if that's clear if you're on a mobile, we've now sourced in that function and we now can use it in our script. So that's making library functions. When we get into offensive tools, there is actually other variables that we might need to use, which are environmental variables. So let's say we've got API keys, or we've got sensitive strings that we don't want to include in our script, or we want to include in multiple places outside our script, and we want to make sure they're understood inside the terminal. Okay, so we can do this as well. The way we would do that, and if I actually just show you on the command line, is it's normal to set in a normal variable. So let's say we've got my var, and we'll call my var hello world. Like so. And what we would do is we would export it like so, okay? So by exporting the variable, it becomes available as a system variable. And just like normal variables, we can do an echo out and the variable exists. So it's a real good way if we wanted to export something, keep it inside of our bash, if you like, inside our terminal, but not actually paste it into our scripts. So that's how we could do exports. What else do I want to teach you in this beginner lesson? Let's have a look at maybe some catching errors. Okay, so let's say we've made some errors. If I go and delete this back out, we can see that we get errors. If we wanted to catch these errors, we could use the set command here with the E option. Okay, and we will look at other options with set. Set's really good if we want to get more verbosity of what's happening behind the scenes, to trap errors, to stop the program execution on error. We'll go into that in depth, but I think right now I just want to get you up and running with Bash. And I think maybe in the intermediate video we'll have a look at more of the options with set. And then when we get to sort of the advanced stuff, obviously we'll be using it all the time in our scripts. So this is what we can now do. So we've added set. And now come to the command line, press Control, and you can see now, rather than have, so I'd actually hope you can see. So before, there was 2 errors on line 5 and line 6, but because we've put the set E option on here, the script's actually ended on the first error. So it never got to the second line, it never continued. If I comment set out, like so, you can see now that we do actually finish the script. It's not exiting on the first error. So that's one use of the set E command. So it's really good if we need to make sure that everything in our script's working and we break on the first error. I suppose on this note as well, we should actually talk about maybe the location of where you might set binaries. So typically, I'm working inside my root inside a folder called bash because I'm just making this up for the not making the tutorial, but like I'm making up a fresh box literally just for this example. But your bash scripts would probably live in either a user location, which would be under your home score directory, and then it'd be like in a bin folder, or typically if it's something that's system wide, it would be under user local bin. So if it's under user local bin, now the reason you'd put your files inside these different locations is right now we are tied into that bash folder. If I move outside of that bash folder and I try and run the script again, you can see that there's no such file, there's no such file or directory. So this makes it now not available, if you like, to the global system. If I was to go back into bash and I was to copy script and we moved it under, say, user local bin, let's just do bash again. And if I go back out, do script sh, you can see now it actually found the script. There's still the errors in it. We still need to put the source back in, but you can see now that it was able to find